Okay, combinatorics. Different chapter than all the rest. Much more university-like, different styles of thinking. Not so much they tell you how to do a process and you follow those steps, but you think through a multitude of different ways that you can solve the problem and try and find the best way, remembering multiple ways. So, in the beginning of the notes, 11.1 starts off, if we have three choices, A, B, and C, well, the total number of ways that we can arrange those things are A times B times C. So let's see what that all means. So first of all, sometimes I'm going to cheat here, and I'm going to do some copying and pasting. So print off the notes, draw this out if you like, press pause, whichever. So we have three t-shirts, three different pairs of t-shirts, and two different pairs of pants. So how many different outfits can we make with these? Well, the fundamental counting principle says simply the number of t-shirts times by the number of pants, so 6. So what does that mean? Well, we can wear the orange shirt with the circle on it with the white pants, or with the green pants, or either of the other two different colors of t-shirts with the respective two pairs of pants to make 6 total outfits. Now, we usually call this blank times blank. And that's going to be a setup we're going to use. Blank times blank. Times blank times blank times blank. We're going to multiply the number of things that we have of each type of thing together to find out the total number of ways. So back in grade 8 or so was the first time we tried probability, and we actually learned to do a tree. So I'm going to call the t-shirts 1, 2, and 3, and the pants 4 and 5, whatever. I'm just associating. So I could draw a tree. And in that tree, I could choose the first t-shirt or the second t-shirt or the third t-shirt. And then I could choose one of the pair of pants, or the other 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 pair of pants. And that's a combination of 1, 4, and then 1, 5, and then 2, 4, and then 2, 5, and then 3, 4, and then 3, 5, for a total number of 1, 2, 3, 4, 5, 6 again. And sure, I could have chosen the pants first. But either way, in Big Red, we're either going to be thinking about blanks with the fundamental counting principle, thinking about the number of ways that we can multiply these things, and we always want to think tree. A tree diagram is a great trick to help us work through these problems. So, same page of notes, just about halfway down. A woman has 4 pairs of shoes. 4 pairs of shoes. 4 times. 3 dresses. 3 times. And 5 hats. 5 equals 4 times 3, 12. 12 times 5, 60. Or 3 times 5, 15 times 4, 60. Either way, 60 different outfits. Next example. A fashion designer has 4 pairs of shoes. 4 times 3 pairs of pants times 2 shirts times 5 necklaces and 6 hats. And that's in the notes, but that's 720 different outfits. Different outfits that person can wear. How many 5-digit numbers are there? Well, I'm going to think about this one a little bit differently. I'm going to start with my blank. So blank times blank times blank times blank times blank. 5 blanks. How many 5-digit numbers are there? And I'm going to list the digits that I have to choose from. 0, 1, 2. I'm going to separate these questions. 3, 4, 5, 6, 7, 8, 9. Now, most people think 0 to 9 is 9 digits, but there's actually 10 digits. 10 digits. So we have 10 digits to choose from. So for the first digit, what are we going to choose? Well, for that digit, we have the digits only 1 to 9 because we cannot put a 0 first. Therefore, in that blank, I'm going to put the number of options, 9 options. Then, in my second blank, I'm going to put below again the different options that we have. And now we have 0 to 10. And that's going to be 10 options. And that's the same for the rest. So I'm just going to say tick, 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 tick. 10, 10, 10. And as you can see from the notes, we get 90,000. And that should ring a bell. We have 90,000 5-digit numbers. Because if we decide on taking the number 9999, or 1 to that number, or 0 to that number for that matter, 0 to 99, well, that is the other 10,000. Yeah, 0 to 99. 0 to 99. That's the other 10,000 numbers. And that's why there's not 100,000 numbers. There's 99,000. Big red. 99,000. 9 times 10 times 10 times 10 times 10. The fundamental counting principle. Again, big red. Look at the first number. We cannot use 0 for that number, because then it would not be a 5-digit number. So we really, really need to think about not only what the given information is, but real life scenarios.